Okay, good afternoon, ladies and gentlemen. Welcome back to another live stream. Today, it's a part 3 of Series Are Not Scary. So, if you are in Cal 2, hopefully you guys find these live streams to be helpful, right? Especially if you are doing infinite series, because they are considered to be one of the hardest topics in Calculus 2. So, before we start, let me just make sure that my mic is working okay. Okay, it looks it's okay. And what did you guys have for lunch? Maybe dinner? I don't know. But anyway though, as always, I have the file in the description for you guys. I also type out the questions and also I have additional practice questions for you guys, right? So after today, we'll actually be done with all the series convergence tests, and then next time we will do power series. And yeah, and we'll actually have a Calculus 2 exam next Wednesday, so maybe after the exam I will do the video solution for my students. So I don't know, we will see. Okay, here we go. Today, the first thing that we'll be talking about is alternating series. So of course, I will review all this right here with you guys. So alternating series test, AST of course. All right, so here is the form. When you have the series, and by alternating, it means that you have positive, negative, positive, negative, or the other way around, negative, positive, negative, positive, and so on, so on, so on. So look for the factor negative 1 to the nth power, and sometimes it might be n minus 1 power. Doesn't matter, it's the same thing, right? And then you multiply by this part, and we call that to be Bn. And for the Bn right here, you will have to make sure that all the Bn's are positive, all right? So here's the deal. This right here converges if two things. First, if the limit as n goes to infinity of Bn is equal to 0. So that's the first criteria. And the second criteria is Bn plus 1 is less than or equal to Bn. Namely, Bn has to be decreasing. And you might be wondering, if Bn goes to 0, isn't that always have to be decreasing? That's not the case, because Bn could have been like this. Check this out. It can be like this, and then up, and then down, and then up, and then down, and then up, and then down. As you can see, Bn is not decreasing, but Bn is approaching 0. So be really careful with that. Okay, so just keep that in mind. And notice that I didn't put down anything if like it diverges or not. Usually, if a series in this form diverges, you should use the test for divergence. Just keep that in mind. But anyway, this is the first part. And one small continuation after this right here is we will talk about the absolute and also the conditional convergence situation. So I will just put that down right here for you guys. Here is a quick note. We say that the series as n goes from 1 to infinity, an, this right here converges absolutely if you apply the absolute value to the an, and this thing right here still converges, right? So you see, sometimes when you have an, it might have some positive, negative terms. And when you have some negative terms, you will have a bigger chance to get convergent. But if you make everything positive, if it still converges, we say that it converges absolutely, all right? So that's what we mean by it converges absolutely, or absolute convergent, depends on how you want to say it. And of course, another thing is that we say, let me put this down right here. I want to make sure I can fit in everything. We say that this right here converges conditionally, right? Conditionally, if the series itself converges. So you don't do anything, you don't do the absolute value whatsoever. If the series converges, but the absolute value version of it, if you apply the absolute value right here, this thing right here diverges. So I'll just put on div. All right, cool. We're still fitting everything on the board. So this right here is usually a continuation after we have the alternating series. And now we have 2 more tests. Altogether, we have about 10. Right? The next one is the ratio test. And that's what we will be going over today as well. And I will tell you that, well, here we will just say the series as n goes from 1 to infinity of an, this right here converges. And for this right here, it has similar flavor with the limit comparison test. But remember, for the limit comparison test, you will have to come up with another series that you know much better, and then you just compare the an and bn, right? For this right here, you don't have to work out like the series of bn whatsoever. You just do this with yourself pretty much. Look at an here and just compute the limit as n goes to infinity of an plus 1 divided by an, namely the next term divided by the current term. And you know what's actually really cool about the ratio test is that you actually apply the absolute value here. So we just care about the size of the ratio of the next term and the current term, right? So we don't really care about the sign in terms of positive, negative. And once you do this, if this right here, let's say we do get the L, right, the number L. If this right here is less than 1, this right here will converge. Well, actually, I wrote down over there already. Right? This series converges if this quantity, this limit right here is less than 1. Well, diverges if L is greater than 1. All right? And here's that thing. If, oh, I'm going to write it down later because I ran out of space. If L is equal to 1, then unfortunately we cannot draw any conclusion. So I will just pause it now and run out of space. And I'll tell you guys this though. Ratio test is great. I would like to use the word great for the situation that you have factorial or when you have the n in the exponent. Right? When you see factorial or n in the exponent, go ahead and give ratio test a try. All right. On the other hand, we have the final one. We have the root test. And it's very similar. And for the root test, I will write this down. Really similar to that. N goes from 1 to infinity. And this right here converges. And you know, in fact, because we have the absolute value, we can actually say this right here converges absolutely. So for the root test as well, but we can just say that converges. Anyway, this right here converges if the limit as n goes to infinity. For the root test, of course, we take the root and we do the nth root. And in fact, again, we also have the absolute value. So again, here and here, we can actually say they converge absolutely. Right here inside, we can just do an. If this right here gives a number L, if this L is less than 1, then you'll see that this right here converges. Well, diverges if L is greater than 1, right? So let me just make the one more artistic. So that's it. Root test, I will tell you, it's great for when you have the n in the exponent. Well, of course, when you take the nth root with the n in the exponent, they can pretty much cancel. And sometimes you may have some variation, that maybe n squared right here. Go ahead and try the ratio test. The root test. Ratio test will still work, yeah. But anyway, though, for both of this right here, I'll just have to put down a note right here in blue. These two right here is inconclusive, meaning that we have to do more work, meaning that they don't work. Inconclusive if L is equal to 1 for both the ratio test and also the root test. So just keep that in mind. All right, so this is the warm up for today. Have a look. I will look at the chat. If you guys have any questions, let me know right now. All right, you guys are doing okay? Guys doing good? If the L is equal to 1, it's inconclusive, meaning that you should try the other tests, such as the direct comparison or the limit comparison, or maybe telescoping, things like that, right? All right, we're good to go? Okay, so Man, yeah, I don't feel like erasing all that because I think it was pretty organized. So yeah, but anyway though, here we will do the questions. So I finally have a collection of videos in terms of going over the series convergence tests. And notice that I'm wearing this Happy Sigma hoodie. And if you guys take a look at the back, it says converge or diverge. I just want to make infinite series less intimidating to the students. That's why I have the little happy face right here. Okay, so here we go. Question number 1. You know the style. Usually I will give you guys some write-out series and then some series in sigma notation. For the first one, we have 1/2, and then you know what? We are going to minus 1/2. I know that's equal to 0, but we'll continue. And then plus 3/8, and then minus 1/4, and then plus 5/32, and minus so. All right, let me know the formula for the nth term. So what exactly is happening? So we will have to put this into the sigma notation. And let's say n start with 1, right? So what's the formula for this? So wait for a little bit. If you guys have the answer, leave it in the chat. All right, Adu Java got it. And then Emmanuel, we will have to be careful because as you can see, the sign alternates and we start with positive. And right here, this is the trouble when you reduce fractions sometimes. In fact, you will have to make this, okay, multiply by 2, multiply by 2. So you can see this is 1/2, and this is 2/4, and then 3/8, which is 2 to the third power. Next, I will multiply this by 4 and 4. So this is 16, which is 2 to the fourth power, and then on the top is 4. So you can actually see we have 1, 2, 3, 4, 5 on the top. And then on the bottom is 2 to some power. But again, the sign alternates. Because the sign alternates, we have -1. And because we start with positive, let's have n minus 1 here. If you put down n plus 1 here, nobody will get mad at you, all right? And then we have n over 2 to the n. So this right here is the series. And now, which test would you like to use? So let me know. All right, so math nerd 1729 got it, and then let's see. So ratio test will work definitely, right? And you know what I would like to do for this one? Ratio test will work, but if you have seen question number 2 already, I want to save that for question number 2 if you guys don't mind. So for this one, let me purposely do it with the alternating series test. All right, so I would like to demonstrate that if you guys don't mind. So here we'll apply the alternating series test, and this is all you have to do it. Pay attention to the positive terms, which is the bn portion here, which is right here, n over 2 to the n. And because we have this factor, so we can use alternating series test. And to do so, all we have to do is we check the following. The first thing, if we take the limit as n goes to infinity of n over 2 to the n, right, which is the bn portion, perhaps I already done just to make it slightly more clear. This right here is the limit as n goes to infinity, and bn is n over 2 to the n. Well, as n goes to infinity, we have infinity over 2 to the infinity. This is technically infinity over infinity, but we can use the list. So this right here is actually just equal to 0. And for my students, you can just go from here to here, and maybe you can just mention by the list, right? And let me just review with you guys real quick. The list says as n goes to infinity, ln n is the smallest infinity, and then less than n to the p's power, and then less than b to the n's power, and then less than n factorial, and then lastly we have n to the n. This right here, p is greater than 0, and this right here, b is greater than 1. As you can see, this is n to the first power, and this is smaller than 2 to the nth power, right? So that's why it just goes to 0. So quick and nice way to do it. Secondly, we are going to check if bn plus 1 is less than bn or not. And you can put on less than or less than equal to, doesn't really matter that much. But I think I have about, I don't know, at least hundreds of videos that I put down less than or equal to, so I'll just keep it in that way. If you put this down, okay, bn plus 1, you just put n plus 1 into here and here, so we get n plus 1 over 2 to the n plus 1. And we are trying to see if this is less than or equal to n over 2 to the n. And just do the typical work. Because everything's multiplied, everything's positive, so we can cross multiply, and by the way, we should say for n is greater than or equal to 1. Anyway, just do the usual thing. So this times that is 2 to the n plus 1. Well, I should technically write down a question mark. All right, this times that is 2 to the n plus 1 times n. Yeah? All right, is this true? Well, we can do the following. This right here is the same as 2 to the n times 2, right? Both of them are positive, so we can cancel. And as you can see, on the left-hand side, we have n plus 1. Is this less than or equal to 2 times n? If you would like, you can minus n on both sides. Cancel this out and have a look. This right here is 1 less than or equal to n. Is this true? Yes, right? Because the series goes from 1 to infinity. So it's so true, right? Therefore, as you can see by the alternating series test, this right here converges. So I'll just write it down right here. So here's the conclusion. Right? The series as n goes from 1 to infinity, negative 1 to the n minus 1, n over 2 to the n. This thing right here converges, and we can just mention that by the alternating series test. Yep, so that's how it works for that. Okay, so just real quick, by the list. This is why I call it a list. As n goes to infinity, you can just compare different kind of functions. Notice they all go to infinities. They all go to infinity, but this right here is the smallest one. And the beauty of using this is that, you see, if you have the smaller one over a big one, that's exactly what happened right here, you get 0 right away. And I can give you guys another example, which is going to be really nice. If you have the series as n goes from 1 to infinity, sorry, this is about limit. If you have the limit as n goes to infinity, ln n over, let's say, n squared, guess what? This right here is equal to 0 because this is smaller than n to the second power. Yeah. And you can do another one. You can, let's say, n goes to infinity. Let's say if you have n factorial over 2 to the n. Anybody want to tell me what's the answer for this one? What's the answer for that one? What's the answer for the limit as n goes to infinity, n factorial over 2 to the n? This right here is infinity. Why? Because n factorial is bigger than b to the nth power, which is the 2 to the nth power. How much bigger? Well, big enough, if you do this divided by that, as n goes to infinity, you get infinity. So that's how you can use the list, right? So if you have my secret weapons, you will see that a lot of these questions are actually going to be easier. So that's question number 1. And again, I just purposely used the alternating series test. Yeah, just for practice for that. All right, for the second question, it's actually the same thing, right? You have the same numbers, but everything's positive now, right? And the truth is, this right here is just going to be the series as n goes from 1 to infinity, n over 2 to the n. So this is the absolute value version of the first one because it does not alternate anymore. For this one though, we cannot use the alternating series anymore. We have to do it with the ratio test. Maybe the root test will work as well, but if you do the nth root of n, you will have to work out a little bit more work for the limit for that. But ratio test, it will be slightly better. So here we go, ratio test. And please do not abbreviate ratio test as RT because root test is also RT. For the ratio test, what we are going to do is we will check the limit. And I really don't know why. Usually when we do the limit, we write down the LIM, right? But every single time, once we are at the ratio test, I will tell my students, you can do it another way. You can just say as n goes to infinity. When you put this down, you don't have to write down the LIM anymore. It's just a lot easier. And you might be wondering how come I don't do that any earlier. I don't know. Anyway, as n goes to infinity, we are going to check that the absolute value, and remember, it was absolute value of an plus 1 over an. But this right here is the same as an plus 1 times the reciprocal of an. Right? So we're going to set it out like this. First part, we have an plus 1. This time, this is the an. So an plus 1, it becomes n plus 1 over 2 to the n plus 1. Right? So that's the an plus 1. And then we will multiply by the reciprocal of an. So you just do this upside down. So you have 2 to the n over n, like so. So this is the expression that we will be focusing on. Good. Now, here's the deal. Break down the bigger exponent and sometimes maybe the bigger factorial. Here, you see 2 to the n plus 1. We can just rewrite it as 2 to the n times 2 to the first. This and that cancel out nicely. Well, this expression is equal to, on the top we just have n plus 1. On the bottom, we have 2n. And check this out. Everything inside is positive, so the absolute value doesn't matter anymore. And yeah, that's pretty much all I have to say. Oh yeah, and I just did algebra, so this is still equal, okay? Well, what does this do? Remember, we still have to take the limit. When you take the limit, please draw arrow. So this right here, as n goes to infinity, n plus 1 over 2n, we just need to care about this and care about that, so we get 1 over 2. Alright? And we took the limit, that's why we draw the arrow. And now, don't just say, hey, this is 1 over 2. You will have to say 1 over 2 is less than 1. Therefore, we can draw a conclusion, and this is very nice. The conclusion is, this series, the series as n goes from 1 to infinity, n over 2 to the n, this thing right here converges, and we know this is by the ratio test. Right? By the ratio test. All right, so that's it. And in fact, I would actually like to mention, as you can see, this right here, we can actually say the series as n goes from 1 to infinity, n over 2 to the n. This right here converges absolutely, because we did a ratio test and we have the absolute value. And this is question 2, right? In fact, question 1, the series as n goes from 1 to infinity, negative 1 raised to the n minus 1 power, n over 2 to the n. This right here also converges absolutely. Why? Because if you apply the absolute value, this right here is the same as that. This right here converges. Of course, that means this right here converges absolutely. Yeah. But you only need to apply the absolute value if the question specifically asks you if it converges absolutely or not. Yeah. If not, then just do this. Okay, so let me just check the chat. Okay, so that's what we have. And now moving on to question number 3. And if you're my student, you can let me know in the chat. I don't know how many of you guys are actually here. All right. And if you're taking Cal 2, of course, also let me know. Yeah. Okay. Question 3. So question 3. Here we have sine of 1 over 2. And then we add it with sine of 2 over, I put down 5. And then sine of 3 over 10. And sine of 4 over 17. And so on, so on, so on. All right? So, real quick, what's the formula for this? And goes from 1 to infinity. What's the formula for the terms? Yeah, Andrea, you got it. And then Abdul Jabbar, you got it. And Math Nerd, of course, you guys will get it. Yeah. Emmanuel. All right, so here, the formula is just sine of n over, notice this right here is the same as 1 squared plus 1. That's how we get the 2. And if you square this, and then you add 1, you get the 5. And then if you square the 3, which is 9 plus 1 is 10, and likewise, this is 4 squared plus 1. Again, you should be familiar with the perfect squares, right? Just keep that in mind. So all this is just n squared plus 1, like so. Now, here is the deal for this though. We cannot use comparison yet, right? And maybe no ratio test, maybe no root test, because yeah, just go ahead and try it. I don't think they'll work out nicely. Anyway, we cannot use the we cannot use the comparison tests because if you look at sine of 1 is positive. Sine of 2 is positive. Sine of 3 is positive. You can just enter down the calculator if you would like and make sure that you are in gradients mode. However, sine of 4 is actually negative. 4 is bigger than pi. It's actually on the third quadrant, and then you actually get a negative y value. So sine of 4 is actually negative. And then sine of 5 is also negative. So the trouble of all this is that positive, 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 negative, negative, and then it's not really alternating in the sense that we want. So we cannot use the alternating series test either. Yeah, so that's bad. So the way to deal with this is that recall, whenever you have sine cosine, one of the most important inequalities is that whenever you have sine of any angle, right, we know the absolute value of this is going to be less than or equal to 1. Right? Of course, we are talking about real numbers. So when you have sine cosine in your formula, in your AN, always keep this in mind. The absolute value of sine or cosine, well, it's less than or equal to 1, right? The biggest value is equal to 1. So this is going to be really helpful, and this is how we are going to do it. Even though the question doesn't ask us that if it converges absolutely or not, but because we want to utilize this right here, it would be a better idea if we check for absolute convergence, right? So this is absolute convergence. And if it works, then we can say that converges absolutely. So just kind of play around with the words. And to do so, we are just going to see, okay, here we have the series as n goes from 1 to infinity. And when you are checking for absolute convergence, you apply the absolute value with this. So you have the sine n, and then you have the over n squared plus 1, like so, right? So let's go ahead and just write down all the steps. First, the absolute value of a quotient is the absolute value of the top over the absolute value of the bottom. So this is the same as the series, and we will have just the absolute value of sine n on the top, and then over the absolute value of n squared plus 1. That's always positive, so you don't need the absolute value for that. So we'll just write it down as n squared plus 1. And now check this out. Thanks to this, we can go ahead and just use an inequality right now and say this right here is the series as n goes from 1 to infinity. And we'll replace the whole thing right here with just 1. And then this is over n squared plus 1. Right? So that's really good. And now you just have to observe and test out if this series converges or not. But this is not so bad because this is just 1 over n squared plus 1. If we don't have the plus 1, you will see this right here is actually less than, and again, you can just put on less than, or less than or equal to, doesn't matter. This right here is actually less than or equal to when n goes from 1 to infinity. 1 is still on the top, but you can just take away the 1 on the bottom. This is true because the bigger that you have on the bottom, the less this is, right? So this right here, as you can see, we will just indicate that. Here we have a nice convergent P series because P is 2, which is greater than 1. Let me just write this down better. P is equal to 2, which is greater than 1. Therefore, this right here converges. So that means we can go back to here and say that this right here also converges. And this right here converges. Why? By the direct comparison test. Because we use inequalities right here, right? So now, as you can see, we check for the absolute convergence and we see that this right here converges. So that means, of course, this right here converges as well. Better yet, you can say this right here converges absolutely. So here is the conclusion I wanted to say. Conclusion. I will write that down. The series as n goes from 1 to infinity, sine n over n squared plus 1. This right here converges. And the reason why is because we have shown that it converges absolutely. So because it converges absolutely. Right? So that will be the write-off for that question. All right, any questions? Any questions? Any questions? So have a look. This is question number 3. All right, so let's go ahead and continue. And again, next time we'll be talking about power series, and maybe I will do like a little emergency live stream on Thursday because I want to have enough materials for the students who are doing this kind of things. Anyway, number 4 right here. Here is the series. We have 1 over ln2, the whole thing raised to the second power, and then plus 1 over ln3 raised to the third power, and then 1 over ln4 raised to the fourth power, and then 1 over ln5 raised to the fifth power, and then so on, so on, so on. One thing I want to make a note before we do anything else is that, note right here, all right? When we have 1 over ln2, parentheses like this to the second power, this means 1 over ln2 times ln2, right? Because the 2 means you do this twice, right? When you have 1 over ln2 squared, this means 1 over ln and then 2 times 2. And for this right here, we could do it as, you can bring the 2 to the front, which is 1 over 2 ln2. But if you have the 2 right here outside of the parentheses, we cannot bring the 2 to the front. So don't say this right here is the same as 1 over 2 ln2, right? This and that, they are not the same. So just notation issues, and sometimes students, when you are taking tests, you want it to be the easy ones, but it's not. Like, don't do that. Yeah. And in fact, if you keep it like this, it's actually easier than this one. But actually, they are both equally easy, in my opinion. Anyway, though, just some notation issue I want to mention before we continue. All right, so anybody want to see? All right. I don't know why sometimes when you guys typing the answers in the chat, YouTube hold the comments. I think it's because just so many notations, so I will have to click so that your comments show. All right. So Timmy, Luca, Abdul Jabbar. And again, I'm just trying to show your comments, so hold on one sec. All right, and Tony. All right, you guys got it. Nice. So this right here, not so bad. You have this number and that number the same. So this is just series. N goes from 2, starting with 2, to infinity, 1 over ln n, and then you raise that to the nth power, right? Now, you see that we have the n in the power. This right here, root test will work. And works really nicely, so let's go ahead and do the root test. And to do so, this right here, we have to just to check the limit, right? So I'll just say as n goes to infinity, and we will take the nth root, and technically we apply the absolute value, and we are going to throw in this expression in here. So that will be 1 over ln n raised to the nth power. All right, the nice thing about this is that, I'll cross this out in, actually, no, I will show you guys the work. The nice thing about this is that when you take the nth root of 1, it's just 1, and we can drop the absolute value because everything inside is positive. And then this right here becomes ln n raised to the n, but you divide it by the nth power. So this is the idea, right? So this is the power. There, just let me just clean it up a little bit. Of course, that can also be 1. So we are just looking at 1 over ln n. And you know what? Remember, we are taking a limit. As n goes to infinity, this will go to infinity. 1 over infinity is nicely equal to 0. Now, we have 0. Does 0 help? Yes, it does. And again, do not just say we have 0 and draw conclusion. You have to mention that because 0 is less than 1. You have to use this as an indicator, right? 0 is less than 1. And by the root test, when you have the limit end up to be less than 1, this series converges. So we will just say, here is the conclusion. The conclusion is that the series as n goes from 1 to infinity, 1 over ln n raised to the nth power, this right here, converges, and we'll just say by the root test. Right? So that's it. That will be the write-off for the solution here. Oh, n starts with 2. Yes. Thank you so much. Yeah, n starts with 2. Nice catch. Thank you. Daniel. Right, thank you. Pedro, thank you. Liang, thank you. N starts with 2. Yes. Yeah. If you want to calculate the sum, you can use Wolfram alpha and let me know what the sum is going to be. And we know that we can get a finite value because this right here converges. And remember, if you look at my back, the questions that we're answering is just if it converges or diverge. So we're not calculating the sum for today, all right? All right, so moving on to the rest of questions, number 5. All right, here is number 5. Okay, here we have the series as n goes from 1 to infinity, parentheses negative 1 to the nth power over square root of 3n plus 1. All right? Okay, if you take a look right here, if the question is only asking you does this converge or not? Well, because we have this factor here, we can just put that aside and say this is the series as n goes from 1 to infinity, negative 1 to the nth power times 1 over square root of 3n plus 1. And you can see that this right here is exactly the Bn that we are looking for. So we can just go ahead and use the alternating series test because, again, thanks to that factor. So let me just write that down right here. For the alternating series test, we have to check two things. First thing, we check if the limit as n goes to infinity. See, I wrote down this again, but I really just don't know why. When I do the ratio or the root test, I just say as n goes to infinity. Anything else, I just put on LIM. I don't know why. I apologize. Anyway, take the limit of Bn, right? And let's see, this is just the limit as n goes to infinity, 1 over square root of 3n plus 1. When you put infinity to here, 3 times infinity is infinity, plus 1 is still infinity, and you take the square root, it's still infinity, but 1 over infinity is equal to 0. So this right here checks. So it's pretty clear to just go from here to here. Number 2, we are going to check if Bn plus 1 is less than or equal to, but we don't know yet, right, Bn. This means we have to make sure that Bn is legitimately decreasing, at least non-increasing, right, in this case. Anyway, this right here is 1 over square root of 3 times n plus 1, and then plus 1. Is this less than or equal to Bn, which is just the original? Well, it's true, but like, let me just show you guys more work so we can see this is legitimately true, right? Anyway, just go ahead and cross multiply. This times that is square root of 3n plus 1. Is this less than or equal to, this times that is the square root 3n plus 3 and then plus 1, which is plus 4. So it's really clear, right? So just doing enough algebra to show it's true. So of course, this is true, checks. So thanks. Conclusion, yeah? Conclusion that the series as n goes from 1 to infinity, negative 1 raised to the nth power over square root of 3n plus 1, this right here, converges. Why? By the alternating series test. And that is it. Again, if the question is only asking you, does this converge? The answer will be yes. And the reason is because by the alternating series test. However, if the question is asking you, does this converge absolutely or not? It does not, right? I will just say, right, this is just like a side note, but the series as n goes from 1 to infinity, negative 1 to the nth power over this right here does not converge. I have a problem with writing C and O together. I don't know why. Yeah, there we go. Does not converge absolutely. Right, so the key is does not converge absolutely, because, right? Because if you apply the absolute value here, you get the series as n goes from 1 to infinity. The absolute value of that becomes, here, let me just write that down, negative 1 to the n. Man, I should have given myself more space, but too late. Because this right here, 3n plus 1. Because this right here, once you have the absolute value, you will just have 1 on the top. You cannot use the alternating series test anymore. This right here actually diverges. Why? You can do a quick comparison by, you can do a else by comparison, limit comparison, oh my god, with the series as 1 over square root of n. Yeah. So anyway though, just some side note. Yeah. Okay, good. All right, So let me know. No, it's not. I need a bigger whiteboard. I should have put down this over there so I will have more space. But yeah, yeah. One of the things that I'm really picky about is I want to be able to fit in everything on the whiteboard, and then I don't like to waste space on the whiteboard. Yeah, and then it's just really satisfying when I can do all the math on one whiteboard. Just like in the beginning of the video today, I was able to write down all the things that you guys will have to know for today on the whiteboard, right? The alternating series test, ratio, and the root test, and also the absolute convergences and things like that. All right, number 6 is a fun one. You actually have seen this before in my previous live stream, but here we go. Series 1 minus 1 over n raised to the nth power. You guys do this real quick. Does it converge or diverge? Again, this is the question, right? Converge or diverge? Just look at the back of my hoodie. Converge or diverge? Don't use log. So again, does this converge or diverge? It diverges. Give a reason why. Go ahead and give a reason why. This right here is not e or 1 over e because this is a series. Be really careful with that. Well, can we really do the root test for this? Let's go ahead and try this, right? Let's go ahead and try this. So this right here is just a root test attempt, right? Because as I told you earlier, when you have the n in the exponent, maybe we should just do the root test. So I'm just saying this is just an attempt, right? Attempt. I don't know how to spell, so let me just not spell that attempt. And I'm using blue, so yeah. Yeah. I wish one day there's like a smart whiteboard that has autocorrect one day. Yeah. Anyway, for the root test, what we do is we check, and now here we go. As n goes to infinity, I don't really know why. Anyway, as n goes to infinity, we look at the nth root, and you technically put down the n absolute value, and you put this down in here, which is 1 minus 1 over n raised to the nth power. This and that cancel really nicely, so we just have 1 minus 1 over n, and especially, everything inside is positive, we don't need the absolute value anymore. So that's what we have, right? Cancel. Well, as n goes to infinity, 1 over infinity is 0, 1 minus 0 is 1. So this right here goes to 1. Uh-oh. We are trying to do the root test, and we end up with 1. Does this 1 do us any good? Let me know. Well, 1 is not undefined. You are not supposed to use that term, right? 1 is not undefined. Does that do us any good? No, it doesn't, right? No, it does not, right? So Abdullah, this right here, I'm sorry if I pronounced your name wrong, but yes, 1 is inconclusive. So this right here is inconclusive. So what does that mean? Does that mean that root test, inconclusive, and then we are done, moving to the next question? No, it does not. If you see inconclusive, this means that, man, we will just have to cross this out because it does not work, and we just have to pick something else to do more work. I know, it's like a sad face. Yeah. But anyway though, 1 minus 1 over n raised to the nth power. Does that remind you any of my secret weapons? It should. What we are actually going to do is, we can actually do the test for divergence. Yes, remember, in order to do all these things, you will also have to remember the things that we have done before. We are going to do the test for divergence. And again, as a note, this is the fact. Well, we take the limit as n goes to infinity, 1 plus a over n, this is an n, raised to the bn power. This right here will give you e to the ab power. And here's perhaps the most confusing part that a lot of students make, and that's why I did the first live stream for. It's a comparison between the sigma notation and also the LIM, right? So just keep that in mind. Well, whenever you are trying to test out if a series converges or not, it's always a good idea to just check the limit of this thing. So we are going to check the limit as n goes to infinity, and we put this down right here, 1 minus 1 over n raised to the nth power. We're just going to check this, right? Just going to check the am portion and take the limit for that. Well, how can we do this? Notice that a is equal to negative 1, a is equal to negative 1, and b is equal to 1. So this limit, by the fact, is just equal to e to the negative 1 times 1, namely e to the negative 1, which is 1 over e. So what does that mean? Does that mean that this right here converges to 1 over e? No, it does not. We are trying to do the test for divergence. And when you have 1 over e, as long as this number right here is not equal to 0, so again, do not say this is 1 over e, you have to say this is not equal to 0, then congratulations, we get to draw a conclusion. And the conclusion is the following. And by the way, we actually did the same question on the first live stream, okay? So we will use that. And the thing is that when you learn more tests, you should not forget about the old tests either. So that's the idea. Anyway, here's the conclusion. The conclusion is that the series as n goes from 1 to infinity, 1 minus 1 over n raised to the nth power, this guy right here diverges. Why? By the test for divergence. Because we have already shown that this limit of an is not equal to 0, so that's why it diverges, just like that. So then you're asking, wouldn't this test never equal 0 since you just putting exponent on e? Oh, I'm saying in this specific form, right? In this specific form. You see, this is the question, the series of this an. And because this form happens to be in the fact, and this is one of the limit that you will have to know. And this is one of the limit that it happens a lot. That's why I have this little secret weapon for my students. Will this ever be 0? This right here, I don't think so. But some variation of it might be, right? So just for example, if you have like n squared here, and then some different a values maybe, but like, I'm not talking about the test for divergence will never be equal to 0. I'm just saying that when you have the limit of this form, it's always going to be equal to e to the ab. So that's the difference. Yeah. All right, so that's that. And then if you need a review of the test for divergence, you guys can watch my first live stream, right? Because I talk a lot more about that in the first live stream. I'm sorry if I cannot get to your question because I do have another class at 3:30, so we will have to finish this up. Today had a meeting earlier, so that's why we started at 2 o'clock today instead of the usual 1:30. All right, number 7. Here we have the series as n goes from 1 to infinity, and we have what? N factorial. Hey, that's the factorial, first time of the day, and the e to the n square. Real quick, let me know which test shall we be doing. Hurry up, hurry, hurry up. Hurry up, hurry up, hurry up. Ratio test will work. I'll do Jabbar, that's correct. Yeah, so let's go ahead and do the ratio test. Why ratio test? Well, factorial, right? That's usually a good indicator. You should use the ratio test. Give it a try. Sometimes it might not work. Well, there are some cases, of course, but usually, yeah. Ratio test says we are going to check as n goes to infinity. Yeah. Anyway, here is the an, and here is the an, and we are going to do the absolute value. We are going to do the an plus 1. So on the top here, it becomes n plus 1 factorial. So let me just write that down. N plus 1 factorial that, and over e, and then the n becomes n plus 1. And then you raise that to the second power like so, right? So that's an plus 1. And we will multiply by the reciprocal of that, so we get e to the n squared over just n factorial. Pretty good so far. Now, we are going to simplify the bigger factorial and also the bigger exponent. For this guy, n plus 1 factorial means you put down the inside first, which is n plus 1. And then next, you put down the next number, which is n, and then you put down n minus 1, and then you put down n minus 2, and so on. But all that is just nicely equal to n factorial. Now, to simplify this exponent, of course, we can just multiply this out, which is e, and then we have n squared plus 2n plus 1, after you multiply that out. And then we can use the rule of exponent and rewrite this as e to the n squared times e to the 2n times e to the first power. And now we are going to have fun because we can do a lot of cancellations. Not really, but like at least 2 cancellations. Ladies and gentlemen, let's cancel this out with that. Also, let's cancel this out with that. Pretty good so far, huh? As I told you, it's pretty good. All right, so after the simplification, we will get absolute value doesn't matter, so don't even need to put that down because everything inside is positive. On the top, we have n plus 1. On the bottom, we have this. Perhaps we'll write it as e to the 2n plus 1. So that's what we have. Now, as you can see, we have just n to some power over an exponential, right? E to the 2n plus 1 and all that. This right here, you can just tell me real quick. It's equal to 0. And again, we are doing the limit. So we can say by the list. Right, so just say by the list. Because this is way bigger than that. How much bigger? Big enough that you will get 0 if you do the smaller one divide the big one and take the n goes to infinity. That's what this is saying. Well, does 0 do us any good? Yes. For the ratio test, if we end up with 0, then please mention that this is less than 1. Therefore, we can draw the conclusion. So let me just write that down here. The conclusion is that the series as n goes from 1 to infinity, n factorial over e to the n squared, this guy converges. Why? By the ratio test. Ratio test. And then we are done. Just like that. All right, so let's go ahead and do the last one, and I have to get ready for my class in 30 minutes. All right, number 8, the last question for the day. here we have the series as n goes from 1 to infinity, and we have 2n, factorial that, and then n to the nth power. Real quick, let me know, just maybe take a guess. Judge the question by its look. Does this converge or diverge? Just let me know. Converge or diverge? Go ahead. Converge or diverge? Converge or diverge? Converge or diverge? Right? Just take a guess. Or maybe you can actually process everything in your head, then go ahead and do so as well. Then you're not guessing, you're just doing the question. That's even better. Converge or diverge? All right, if you say this right here converges, then I'm sorry, I don't think it converges. All right, let's see what's up with this. We have the factorial and also the n. Ratio test is a good idea. Right? So here we do the ratio test. And usually the ratio test is one of everybody's favorite because it has a good indicator that when you should use the ratio test, right? Because of the factorial. And then you can do a lot of algebra. I think this is one of the things that students might like the ratio test more than the other ones. Anyway, take the limit as n goes to infinity. All right, here is the an. Go ahead and put down an plus 1. So be really careful though. We have 2, and the n becomes n plus 1. And then after that, right after this, we factorial this, okay? And then divided by the n becomes the n plus 1, and then raised to the n plus 1 power, like so. So I put on parentheses, n plus 1, and then n plus 1. And we will multiply this by its reciprocal. So we have n to the n, n to the n over 2n in the parentheses, and then we factorial that, like that. So for this right here, the trick is just to simplify the factorial carefully and also simplify the exponent carefully on that. Here's the deal. This right here is the same as 2n plus 2, and then you factorial that, right? So this is 2n plus 2 factorial. How do we simplify that? Well, we first write down 2n plus 2, that's the first guy, and then we multiply by the next one, which is 2n plus 1. And then the next one is just 2n in your parentheses. And then the next guy is 2n minus 1, and then 2n minus 2, and so on. So all this becomes 2n factorial, like so. Simplify this. The base stays the same. So we have n plus 1 raised to the nth power times n plus 1 raised to the first power. All right. Happy canceling. This and that cancel out. Cannot cancel out. But this guy, we can cancel out, but man, I ran out of space. That's slightly bizarre. So how can I write this? I'm going to just kind of fix this a little bit. Hopefully you guys don't mind. I told you guys how picky I am. Anyway, I write down the check, right? So just check as n goes to infinity. Okay, now I feel much better. Anyway, the 2n plus 2 is the same as 2 parentheses n plus 1, and of course we still have the 2n plus 1, right? So this guy and that guy cancel out nicely. Okay. So far so good. And now what's the result after all the algebra? On the top we have this times that. So 2 times, let me write it down like this. 2 times that, so it's 2 times 2n plus 1. Okay. Well, we still have n to the n over that. But both of them have the nth power, so I'm going to write it as n over n plus 1 raised to the nth power, like so. Right? So now, how can we simplify this? Well, I'm going to bring up the fact again. Maybe just write it down real quick. Because here's the thing. If you put infinity into here, you get infinity. Well, inside here you have 1 because you just care about this and that, so it's actually 1, right? And then if you put infinity to here, you have 1 to the infinity. But unfortunately, we cannot draw a conclusion on this, right? So we cannot draw anything. We cannot draw any conclusion on this. But this right here, it's actually really similar to the fact. Let me just put that down one more time. Why did I always write down A over B? Bn is equal to e to the ab. Well, you see that we have 1 plus a over b. This right here is n over n plus 1. Imagine if we do the reciprocal. That would be much better because then we'll just have n on the bottom and then we can split the fraction. So here is how we are going to do it. Let me actually, I write it down right here. Hopefully you guys don't mind. We still have the 2 and then 2n plus 1. And for this, I'm going to just turn it upside down like so, n plus 1 over n. But I will actually do the negative power here. So this becomes negative n. So I can just do a reciprocal like that. And now check this out. This right here is 2 times 2n plus 1. And you know what? I'm going to write it down like this. It's going to be cleaner. I just realized how I can write it down cleaner. Sorry. I'm going to do this limit on the side here. So hopefully that will make everything more better. More better, yeah, I guess. If you look at this, the limit as n goes to infinity, just that part, right? N over n plus 1 raised to the nth power. This right here, well, you can write this down as the limit as n goes to infinity. Do the reciprocal, so you have n plus 1 over n, and then raised to the negative nth power, like so. Split the fraction, so this right here is the limit as n goes to infinity, and then you have 1 plus 1 over n raised to the negative nth power. There we go. In this case, a is equal to 1 and b is equal to negative 1. So this right here gives us e to the negative 1 power again. All right? So now, remember we're still taking a limit. The limit of the product is the product of the limit if each limit exists. Have a look right here. This right here is going to approach. We still have the 2 right here, no big deal. And for this guy, it's going to give you infinity. Right? This guy is going to give you infinity because n goes to infinity. And for this, by the blue portion, it's going to give us 1 over e. So all in all, this right here becomes what? Just infinity. So this right here is actually just going to be approaching infinity. Therefore, this right here is greater than 1. So that is what? Diverges, right? So finally, I'll just draw the conclusion here. Conclusion. All right, let's see if I can fit in everything here. Here we have the series as n goes from 1 to infinity, 2n factorial over e to the n squared. This guy diverges by the ratio test. Factorial that, why not? All right, so hopefully that's clear. This portion, this kind of limit happens a lot. Then in that case, use one of the sqrt that I have demonstrated before. So have a look. All right, so do you guys have any questions? If so, just leave in the chat real quick and then I'll try to answer questions. Oh, right, thanks. I was still thinking about question number 7. This right here should be n to the n. Yeah, this right here should be n to the n. Yeah, math nerd 1729. Thank you so much. I still like the 2021 number that the wrong operation, the wrong order of operation question that you put on Twitter. Very nice. It was a mistake. It was a mistake. with actual stick. But anyway, just like that. Yeah, super good. You got the mistake with the actual steak. Because who doesn't love steak, right? All right. So this right here is it. I will do another live stream next Tuesday, and I will try to do another live stream this Thursday so we can get started with the power series. And if I do that, it will just be an introduction. I will give you guys some ideas about the power series and things like that. And you can pretty much see how I introduce the concept of power series to my Calculus 2 students. And for sure, next Tuesday, I will do the technical work and maybe some computational things, right? So that's it for today. Thank you guys so much for watching. See you next time.